Hi, my name is Sanjeda Salim and I'm currently in my fourth year of chemical engineering at the University of Waikato. My final year project for the Engineering Design Show 2021 is on water treatment plant integration, automation and control. This project was supervised by Dr. Graeme Glasgow from the School of Engineering. The following contents will be explained in this presentation, which is what is primary stage water treatment, why it is important, the lab scale plant development, findings from research and design, as well as my conclusions and recommendations. I will also include a demo of my prototype. So, what is primary stage water treatment? This is the first and most important stage in drinking water treatment, as it removes solid particles from the water so you have the clean and clear water you do for drinking. This is done through three major steps, which is coagulation, flocculation, and sedimentation. This is also normally carried out in a clarifier tank. Coagulation is when a chemical is added which neutralizes the charge of particles in the water. This basically stops the particles from being suspended, or in other words, being able to float in the water. Then flocculation occurs, which basically clumps the particles together to create larger particles. These larger particles then fall to the bottom of the tank through a process known as sedimentation. As a result of this, the dirty particles fall to the bottom and the clean water free of particles surfaces to the top. Now, why is it important to model this in a lab? Having a lab-scale version of this process will help facilitate learning, as it will help students visualize and understand the process better. It will also help with research and can be used to study, optimize, and design current and future plants. The aims of this project were to successfully construct an automated lab-scale hopper-bottom clarifier with an automated dosing system, to demonstrate the primary stage of drinking water treatment process involving coagulation and flocculation, as well as to successfully construct this innovative lab-scale plant which can be used as a teaching and research resource to facilitate learning. In order to do this, the lab-scale plant was developed as per the schematic drawing. A coagulant chemical was used, with the chemical being aluminum sulfate. Here you can see a raw water tank, sludge output, hopper bottom clarifier, and treated water output. These were all used to develop the lab scale plant. Several sensors and controllers were used to automate and control this process. Two turbidity sensors were used. These basically detected how many particles there were in the water and were used for feedback and feed-forward control. A flow meter was also used, and an Arduino controller was used to control the pump. The following findings were that an optimum coagulant dose of 22 milliliters per litre was found. A flow rate of 17.54 litres per hour was required for a retention time of 30 minutes, and the turbidity sensor readings were found to be significantly noisy and unreliable. Flocks were indeed found to form at the bottom of the clarifier. The following conclusions and recommendations that were drawn from this research and design project were that the turbidity of water was reduced but not significantly. Further testing of various parameters is required for a distinct sludge blanket to be formed, and signal processing is recommended for better control. I will now include a demo of my prototype.